Good morning, everyone. That's good. I'm Ong Wu, Program Manager in Azure Storage Team, responsible for Azure Disk and Files. I'm excited to be here, along with my colleagues and friend, Sirius Kutian, who is a subject matter expert and Program Manager for Premium Storage.
Okay.
We'll be presenting it together.
Yep, thanks, Ong.
Okay.
Okay.
So before we deep dive into Azure Disk and Files, let's go over some of the Azure storage talks at 8 night. We are the third one, overview and deep dive from Azure Disk and Files. First two are already done. You can view them in they are primarily about object storage, also known as blob, and you can view them on the channel 9. So I'm not going to go a lot into detail about that. But third one is ours. And then we have another one tomorrow on storage security topics, which will cover all the security practices and methods to secure your data in Azure storage, including encryption at rest. So go to that session. That's going to be a good one, too. This is our agenda. I will go over Azure Disk and Files, briefly go over the overview, and then we will deep dive into a couple of topics. For Azure Disk, we will discuss about migration. How do you migrate from standard disk to premium storage? Our backup and disaster recovery story, and then best practices, especially in the performance. For Azure Files, brief overview, and then we'll deep dive into snapshot capability that which we will be shipping soon, and then go over the performance best practices also. For both of those topics, I will outline also our roadmap for Disk and Files. And we have a treat for you. We have a customer experience session that we will bring up a customer and a partner as part of the Azure Files discussion to go over their best practices and how they implement Azure Files in the real-life story. So we have Stephen Cotton and Yap from Talon coming on board. Stephen with Robert. Stephen is a customer who is with the Robert Burt's group. Let's briefly go over Azure Storage for a moment. It's a foundational building blocks of Azure Storage. And all of our internal properties, including Skype, OneDrive, and Xbox, leverage Azure Storage directly or indirectly. And of course, we have a lot of external customers leveraging it, right? So I have a quiz for you. We're talking about hyperscale here. I know you got thrown. Hear this word, hyperscale here, but we are really hyperscale, right? So let me ask this question. How many of you can you guess at how many transactions per second that we process in Azure Storage? Any takers? All right. 12? So someone was pretty close. It's 19 million transactions per second, right? So 1 second, 19 million. So think about that, hyperscale. This session will last another 1 hour or so, right? In that time period, we would have processed 60 billion transactions, and then would have ingress and egress 2 petabytes of data to Azure Storage. This is the scale that we're talking about, right? So before I joined Azure Group, I was with part of Windows and all that, and then joined Azure Storage. We celebrated when we hit 1 million mark. There was a big thing with cake and all that. Then we stopped celebrating because every time, we have to celebrate then, we have a problem with, cholesterol, I guess. So, all right. So I'm not going to go over every key points here. But what I want to highlight is that in addition to hyperscale, I want to highlight the durability aspect of that, right? We are the only cloud provider who gives you a promise that we will never lose your data and that we haven't lost. How do we do that? We commit 3 replicas of data, and we provide strong consistency. What we do is that we write 3 replicas synchronously and then do not give you the acknowledge back until we persistently write 3 replicas on our platform. Okay? So that's our durability promise, and this is the durability promise for all Azure storage offerings. The rest, our previous session of blog blobs about object storage, they cover it, so I'm not going to go over detail, but I just want to hit hyperscale and then durability really quick. Cloud services in general are broadly defined as IaaS, infrastructure as a service, or PaaS, platform as a services. IaaS is where you bring you build your own infrastructure on the cloud, and then PaaS is where you have application and then you have higher level, leverage the platform. So Azure Disk and Files fall in the IaaS category. What that is that infrastructure as a service, you can deploy your infrastructure and then use disk. Azure Disk is a persistent disk for IaaS VMs, and the Azure File, fully managed file service. I'm not going to go over that a lot in this slide because we will be talking primarily about those two topics for this session. However, I want to talk briefly about other 3 services that we have for PaaS. Object storage, it's a highly scalable storage, a massively scalable storage in exabyte scale with tiering offering. We offer standard for hot storage, and then cool storage for infrequently accessed data. That's currently available right now. And my colleague Wamshi had a session on this, so go watch Channel 9. And then tables, it's a NoSQL offering for semi-structured data. And then Q is a reliable messaging service for inter and intra services, right? So those are other part of Azure storage offering that we have. And then they all are built on highly durable, secure, and then fault-tolerant platform. All right, let's get into this overview. What is Azure Disk? This is a persistent storage provided for IaaS VM. There's a one-to-one relationship. You spin up a VM, and then you attach a disk, and then this VM can only access a disk. So think about it as a user server, and then you attach a hard drive to that. But the only difference is that you store the data that you store in the Azure disk is stored in the Azure cloud. That's Azure Disk. So we currently have 2 offerings. Standard disk runs on magnetic drive, HDD, and premium disk, which runs on SSD. And they both are backed by page blob. It's a different type of blob storage, highly optimized for VM workload, IaaS workload. Core capabilities, you can achieve 80,000 IOPS and 2 gigabytes of throughput with the high-scale VM. This is the best that you can see in any cloud VM offering right now. Currently available in 26 regions for premium storage, and we will continue to expand premium storage in all regions. Actually, Azure has 30 regions, and then by end of this year, we will be in all regions, and then we will make a practice, or we will make a requirement of rolling out premium storage in every new regions that we launch. So So essentially, what we're saying is that we have more coverage than AWS currently have in terms of premium storage and standard storage also. We also offer server-side encryption. You can turn on encryption at rest for both standard and premium. And then also, you can secure the data through BitLocker also. Another 5 bullet points are our key differentiator. So I mentioned about 80,000 IOPS that you can achieve with VM. But we also offer unique capability in blob cache technology so that you can turn on caching for both read and write. That's none of our competitors provide that feature capability right now. With that, you can even achieve higher than 80,000 IOPS on a VM. That's one of the demos that Sirius is going to provide it to you. And he's going to tell you how you can achieve that. I talked briefly about enterprise-grade durability. What that means is that when you run performance workload on-prem, you have to configure RAID-like solution, like you keep through replicas and stuff like that. You don't need to do that when you're using disk. We keep through replicas for you, and then we have a promise of never losing your data also, right? And we recently shipped snapshots for backup, but one thing that our differentiating offer is that we offer you differential backups. With the API, you can go to the granularity of backup and then do the differential. Sirius has a slide specific for that. And ability to expand disk in place. We offer, let's say, you provision a smaller disk, and then if you want to enlarge this disk, you don't have to create a new disk. You can just increase the size on fly, and then you can keep writing to that disk. That's another differentiating offer. And REST interface for developers, what it does is that the disk that I mentioned, you could mount it to the VM, and then only that VM can access. Or REST interface, you can use REST interface to access that page block from on-prem or from Azure VM. That our competitors do not provide the feature to. One of the most frequently asked questions is that, when do I use standard or premium disk? So I will simplify that for you. All production workload, we recommend you to use premium disk. Standard disk is like DevOps workload, or you have infrequently accessed data with lots of storage space that you need. You use standard storage because you have cost advantage there. But otherwise, we recommend you to use premium storage. I hit a couple of first 2 points. I covered that in the previous slides. But one thing that I want to call out between standard and premium storage is that premium storage provides single-digit latency. And then with standard disk, you will have a latency variability. So the reason that premium is that we provision IOPS for you. That means we say, hey, if you purchase P30, we give you 1 terabyte of space, and then 5,000 IOPS you provision. So we reserve your ability to achieve that number of IOPS in our storage platform. Standard, we do not. So I mean, we have the numbers there, but you can achieve, those are max number, right? And most of the time you will achieve it, but sometimes we will miss it. So that's the difference. Disk roadmap. So premium disk, premium storage, we launched a year and a half, a little more than a year ago. And we gather your feedback. And then we recently launched some of the key features. So we provide Azure backup support. So what you can achieve is that you can get application consistent copies of that data. You don't need to take down a VM or anything like that with fine-grained granularities and rule. You could get the backup support there. encryption at rest, we launch it for both standard and premium disk. Azure Site Recovery is in preview. That allows you to replicate your on-prem infrastructure to Azure platform using Azure Site Recovery. So it's an active configuration. One goes down, the other one is up. Incremental snapshot copy. You can use REST API to do incremental snapshot. If you want to write that allows you to do like, hey, if you want to write your own backup, you can use that API to implement that. So those are the features that we recently shipped. However, in the future, we plan to offer more disk sizes, smaller disk sizes in the horizon, and then we intend to offer larger disk sizes also. So right now we hear that, hey, you only have, especially in premium, 3 disk sizes. So hey, I don't need 128 gigabytes for P10, but I don't need that many IOPS. We'll provide that. There will be a smaller disk sizes available. And we are working towards making disk analytics available for you also, so that you can look at more granular. I mean, we have a way to like look at IOPS and latency, but we will provide disk analytics enhancements so that you can view it as part of the storage analytics. With that, let's run some demo to highlight the performance characteristics that I mentioned. I mentioned that you can achieve up to 80,000 IOPS with no caching at all, and then you can achieve more. So let's more with the Azure Blob Cache feature. Let's look at how much we can get. Sirius, you want to take it away?
Yeah. Okay. Hey, folks, hi again. My name is Sirius Kuttian. I'm a program manager on the Azure Storage team. For the next section, we will start by demoing some of the capabilities we just talked about. Ong is getting the demo machine set up. So for this demo, we will use a GS5 VM. GS5 is the largest VM in the public cloud right now. That's the largest VM on Azure. It's a massive VM with 32 cores, lots of IOPS, lots of throughput, ideal for really large workloads. So we will look at the IOPS and throughput capabilities of that VM.
All right.
So for the first demo, we will show the IOPS, max IOPS you can get with that VM. So Ong is running a workload configured for high IOPS. So he's using smaller IO sizes and running heavy workload on that VM. So we configured several disks with caching turned off. That really allows us to see the performance of the VM, the backend storage, not coming from the cache. So what you can see here is that the IOPS reaching very close to 80,000 here for the configuration that we are running. This is a massive amount of IOPS coming from a single VM. So this is suitable for a lot of OLTP workloads. If you have, let's say, a very large database, or online OLTP database on-prem, so this VM will be a great option for migrating that to Azure. You may have other scenarios that may require high throughput. Let's say you want to run sort of a data warehouse type of workload, or maybe backup recovery that requires high throughput. So we will look at the high throughput option as well.
Okay.
Let's switch to the high throughput.
Sure. I just want to highlight a couple of things with what Sirius said. So it's approaching 80,000 IOPS. We didn't warm it up intentionally, but you could easily achieve that 80,000, right?
Okay.
I mean, it's approaching that. So
Yep.
let's show the high throughput one.
Okay. So for high throughput, we will run the traffic with larger IO sizes. That's how you will get higher throughput. So here he's running it with 256 KB as the IO size. Okay. Here, as you can see, we have over 2,000 MB per second on the single VM. So this is, again, really ideal for very large database workloads, something that needs very heavy lifting, high throughput. You could run multiple databases here, or you have a very large requirement, very large workflow requirement, you can use a single VM for that. If you have many customers that run large SAP deployments using GS5 VMs, so GS5 has been one of the most sought after VMs. In fact, do you know how this VM gets its name, GS? Here, the G stands for Godzilla. It's a monster, and that's how it gets that name.
All right, so let's move on to.
All right, let's move on to another thing. Now, this is the max capabilities of the VM, right? I mean, this is the max capability that we talk about of the VM. Now, there is one other thing that Ong touched on, which is the blob cache capability that you get from all the premium storage VMs on Azure. Here, we have a layer in our compute that has an advanced caching capability. We call it Azure Blob Cache that can leverage the local SSD storage, part of the local SSD storage of the host, compute host, and the RAM, and to really cache some of the IOs on the compute host and deliver or increase the IOPS and throughput of the VM using that. Now here, we ran this workload on this VM, GS5 VM, with a combination of some disks using the cache and some disks not using the cache. And as you can see here, we are getting close to 200,000 IOPS from a single VM. There's no other cloud provider out there right now who can give that. So if you think of your typical database, large database deployments, you will have a combination of disks that will use caching, and read cache, and some disks that don't use cache. For example, if you have a SQL server or any database deployment, you will have log disks that don't use caching. So you will turn off caching. You have data disks that may use read-only caching. People run large queries where the data, a lot of the results can come from the cache. So you will have a combination of read cache disk and non-cache disk. And with the right configuration, combining these two, you can get really massive performance from a single VM. That's the unique capability of the Azure VM. Before we move on, I do also want to show the throughput performance you can get from this. So let's look at the throughput optimized workload for the same configuration of combining cache disk and non-cache disks.
Okay. So one thing is that we're running it on the live VM right now in US East 2. So this is not a VM running on my laptop.
I don't think your laptop can hit the 200,000 IOPS.
Yeah, that's the problem there also. All right, let's see.
Okay. 3,500 MB per second throughput from a single VM.
All right.
All right. Okay, that wraps up our demo for current session. Thanks, Ong.
All right, let's switch back to.
Yeah, let's switch back to the slides. So before we move on further, I do want to talk briefly about. Do I have the clicker? Okay. I do want to talk briefly about how we can optimize the performance to get the kind of numbers that we just showed. First of all, we had a deep dive in the last year's Ignite. We got a detailed session on optimizing or best practices for premium storage performance. We will not repeat at that level of details in this session because we have other newer things to talk about. I encourage you to watch the recording from the previous session, and you can learn a lot about how to optimize the performance. The most important things to talk about are these. One, when it comes to performance, when you look at the performance numbers, performance configurations, there are two separate parameters. There is IOPS, there is throughput. So there are separate limits for independent limits for these. So you would want to look at these as separate entities with its own limits and enforced independently. So when you plan your workload, you must make sure that your configuration can give you the required IOPS or required throughput separately. The next thing I want to talk about is the VMs and disks. So here again, VMs and disks are separate objects with separate limits. So when you use them together, you must make sure that you can get the IOPS and throughput separately from each of those. As an example, if you were to have a DS3 VM with a single P30 disk, max IOPS you get from this configuration will be 5,000 IOPS. Even though VM could do more, your disk will get capped at 5,000 IOPS. Likewise, max throughput you get from these will be 128 MB per second, not 200, because the VM will become the bottleneck here. So you have to really look at your workload needs and plan the right VM and disk configuration based on what you need. Okay. Next, on optimizing traffic patterns, we talked about that in detail in the last Ignite session. The important thing I want to call out here is about the burstiness of traffic. So you really want to minimize the heavy burst. The most important scenario, or most frequent scenario, is the application like Cassandra, where it has it kind of has a buffer to keep IOs in that buffer, hold IOs in the buffer, and send them all at once when the buffer becomes full. What you need to watch out for is that in that kind of pattern, you will see a burst of IOs, then nothing for a while, and then another burst of IOs. Here, you would want to keep your burst size really minimal, and our recommendation is that your buffer size in this case must be less than the 5% of the limit limit of your VM or disk. As an example, if your limit is 500 IOPS, then your buffer size needs to be less than 25 IOs. That way, you can make sure to get the best performance from your VM and the disk. Okay. So that pretty much wraps up the session on the disk overview. Next, we will deep dive into the disk area. So here, you will learn about the best practices for migration and how to configure backups for your VMs and other important best practices for getting the best out of your Azure deployments. So let's start off with the migration. So here, when we talk about migration, we are really talking about two different scenarios. One scenario could be that you have an Azure deployment currently that uses standard storage disks. And you have important application workload running on that. Now you've seen the performance of the premium storage, and you want to really move that to a premium storage-based VM. But the problem is that you have a workload already running, and there's concerns about how we can safely move. Likewise, you may have an important workload running on-prem, and you want to move to the cloud. You have the same scenario there. So migration scenarios cover both these. Standard storage to premium storage, or on-prem to Azure, you will pretty much have the same process. And high level, you have two ways to do it: offline migration or live migration. So in the case of offline migration, here you will have a downtime, long downtime for your application. You will shut down your VM while you migrate your data. So let's look at how a typical process for that is going to be. So in this example, you have a VM using standard storage, and you want to move to a premium storage-based VM. So you will your VM is live at this point, and you will use a tool called AZ copy for migrating the data. So let's step through this process. So first step will be to shut down your VM, because you cannot do the migration while VM is running, obviously. So you will shut down the VM. So at that point, your disks are disconnected from the VM. VM is still there, but it's disconnected. And once it's in that stable state, you will create snapshots for all the disks. So that gets you a consistent state of the disk that you can migrate. Okay, once you have the snapshots, the next step here is to start copying the disks to your target premium storage account. So next, you need a premium storage account for moving the disks. So once you have the premium storage account, you will kick off the AZ copy tool for doing the migration. So here is where most of the challenges will come in with the offline migration. So migrating the data from one place to another place using any tool is going to be a slow process. It's going to take time. And the time will depend on how much data you have on those disks. Roughly, you can say you will be able to migrate about 100 gig per hour per disk. If you have lots of disks, and you can do in parallel. So your bottleneck is really going to be the disks with the most amount of data, and you can estimate the downtime based on that, and you can plan your migration according to that. Once you completed the copying the data, the next step will be to create the VM, create a new VM using the disks on the premium storage account. From that point, your downtime essentially ends, and you have the new system working at the other end. And once you validate the new environment, new VM, you can then get rid of the old environment or archive it. That is a typical process for offline migration. So as you can see here, it's a longer downtime here. It may or may not be ideal for all the cases, depending on the criticality of the application. So you have to make the right decision based on that. So that's where the next option comes in, where you can do the migration, live migration, where your application continues to run during most of the migration replication process. Thing is that you have to use a migration solution for doing that effectively. Azure Site Recovery is a Microsoft solution that enables that. I'll go through that, the details of that. So you can essentially migrate the VM live from standard storage to premium storage, or on-prem to Azure using ASR service. And the downtime in this case will be much shorter. There's still going to be a downtime when you switch over, but it's going to be a much shorter downtime. Okay? So let's look at the steps for migration. The first step will be to create a site recovery vault. These steps are very specific to ASR. There are also other third-party solutions like Commvault that could be used for live migration for certain scenarios. And they will have their own steps. But high level, these steps will pretty much look like this. So once you create the migration vault, the next step, which is really the main part of the configuration, is to define your setup, define your infrastructure for migration. So here is where you define your source environment, target environment, and configuration option for your replications, and so on. Once all that is set up, you're ready to start the replications. So here, you'll go to this site and enable the replication. So the ASR then starts replicating your data. So at this point, you're not ready to switch over yet. It will still take time to replicate all the data, but the great thing is that your application still continues to run wherever it is, so you don't have a downtime. So then, once the replication completes, you can think of validating your, testing your new system. So you can see the status of the replication on this page. You can see the replication health here. If the replication health is good, that means that the target is mostly caught up with the source data, and you can then switch over if you want to. So the next step at this point will be to test the failover. You don't want to do a failover without testing it. So here, when you test it, here, it will bring up the target site. You can do all the validation, make sure everything is in good shape. Then once you're satisfied with that, then you can do the real failover. So here is where you'll shut down your current instance and do a failover to the new instance. Then after that, you're pretty much done. Okay? The next topic we will talk about is the backup strategy. So backup is another important aspect, as you know. So if you have VMs on-prem, I'm sure you already do backups, and you already have RAIDs to make sure you are protected from failures and so on. The great thing about Azure, as Ong said, we already have enterprise-grade durability. You don't have to really worry about local disk failures and that kind of problems. And you don't need to use RAID. We really give a promise that we don't lose your data. However, there are still going to be scenarios where you want to have a backup for your VMs and disks. There could be scenarios, application-specific scenarios, or your own data-specific scenarios where you would want to go back to a previous version of your data. There could also be a regional disasters, and you may want to protect from that by having a DR-compliant backup in a different site. So those are the scenarios you really need to worry about here. And in that context, the most important thing for these backups is that you want to have a reliable backup that you can use for recoveries. When I say reliable backup, essentially we are talking about a consistent backup. Consistent snapshots means that the backup should represent a steady, stable state of your application. You don't want to create a snapshot when a write operation is in progress, write operation is in flight. Then when you recover it, you could get inconsistent results or sometimes corrupted data. Let's say if you're using striped disks, and if the disks are not in sync, then you can restore the striped volume. So you don't want to do that. You need to make sure that the snapshots are consistent. And doing that with running VM is a challenge because running VMs constantly produce writes to the disks. So creating consistent backups for the running VM require additional steps. So we are going to walk through those steps here in the next part of the session and talk about a few options you have for creating consistent snapshot backups. So high level, there are three options. The recommended option is to use a backup solution that is out there. Azure Backup Service is a Microsoft solution for creating consistent backups for Azure VMs. Another option will be if you don't want to use Azure Backup or another third-party solution like Commvault or Veritas Net Backup, something like that. If you don't want to use any of those, or if you have a very custom need to create a backup solution, then you could build your own backup solution. We don't really recommend that. The reason is that this is not a trivial task. It has a lot of complications. But I'll go through the steps in the next slides. But that's another option if you want to pursue that. And third option is to do the backup with the downtime. That may not work in all cases because there is a downtime. But if you have a dev test VM or a scenario that has a planned downtime periodically, then that option may work for you in some cases. Now let's go further into the first option of using Azure Backup or a similar third-party solution for doing your periodic backup. So as I said, this is a recommended solution. This works for pretty much all Azure VMs, premium storage disks, standard storage disks, Linux, Windows. It works pretty much all scenarios. So this will be the ideal recommended solution for you. For Windows, it provides advanced application consistent backups. For Linux, you will get file system consistent backup, which is pretty good as well. And then there are other flexibilities you have in terms of what kind of redundancy you want for backup, and so on. Important thing is for mission-critical application, you want to go for geo-redundancy. That's what will protect you from regional failures. Okay? We have more information on some of the contents available at the links here. You can check out more details there. Let's look further into the second option of creating custom backup. Now, as I said, this is going to be a complex process. The reason is that in order to create consistent snapshot backups, you have to get all the disks synchronized by freezing the IOs and flushing any pending IO operations, and then create the snapshot of those disks. Then those snapshots are going to be synchronous and consistent. So doing that will need some amount of complex development work. For Windows, you will plug into Windows Server Backup or Volume Shadow, those technology depending on the Windows version, and you will also need a backup provider that you need to provide a service that you need to build. And for Linux, you will need to use some tool like fsfreeze or something that can freeze the file system for creating this backup. And once those snapshots are done, snapshot is created, you have the second step of copying these snapshots to another storage account, another location where you can have a DR backup. So here is where the incremental snapshot copying that Ong talked about earlier becomes really handy. So when you have these snapshots, you want to be able to copy only the data that changed. So in the next slide, we'll go into details on how to do that. So we have a new version of Get Page Ranges API that implements the incremental copying of data between snapshots. So you can call the API with current snapshot and previous snapshot as the parameters, and it will give you just the delta between those snapshots. So you're in the old world, before we had this API, if you have to back up a snapshot, you have to copy the whole snapshot every time, and that is going to be a massive operation, especially if you create frequent snapshots. In the new world, much easier. You can create snapshot very frequently, and you just copy the delta between snapshots every time. And the picture pretty much looks like this, where you have a source or primary VM on the left side, and your copy, where you are trying to back up, on the right side. So you will create snapshots periodically, and you'll copy the snapshots over to the other end. And when you do the copy, you call the Get Pages Ranges API to only copy the delta to the other end. And you will create snapshot at the other end as well. So we have a document that gives a lot of details on how this process works. And I encourage you to look at that document to learn more about it, especially if you're planning to build a custom backup. Okay? Now look at the third option, to do the backup at the downtime. It's a fairly straightforward process. We will shut down the VM and then create the blob snapshot. When the VM is down, the disks are in a consistent state, so you can create blob snapshot at that time. That's the purpose of shutting down the VM. And then as soon as the snapshot is created, you can start the VM backup. So here, downtime is just going to be just a few minutes, but still there is going to be downtime. And once the snapshots are created, then you need to then copy the snapshots over to your backup site. Okay. Now let's look at how to restore from the backup, if at all you have a need. If you use the backup solution for your backup, process is easy. That's going to provide a solution for restoring the backup. But if you use your own custom backup, then you run your own for restoration as well. So the process will look like you identify which snapshot or which backup you want to restore, and then you copy those snapshots, specific snapshots, to a new blob. And once the copies are done, you create a new VM pointing to those disks. And so now you have a new VM, and you can get rid of the old VM once this is validated. That is a high-level process. And I've shown the picture here using your previous backup solution, and you can see how that data flow looks like. Okay? So in the next section, I want to go over a few best practices that are most important for building a reliable system, and some of the best practices for configuring various applications and so on. So for overall reliability for mission-critical applications, as Ong mentioned, premium storage is the recommended storage type. This is especially important for I/O-intensive application like databases. If you do use standard storage for your VM workloads, there are a couple of things to keep in mind, a couple of best practices. One, make sure you have less than 40 disks in the same storage account. There is a limit per storage account, 20,000 IOPS that you don't want to exceed. And you can turn on storage analytics to monitor the utilization of the storage account. And for redundancy, for mission-critical application, you really want to have multiple VMs just in case one runs into a problem. So you can achieve that using VM availability sets feature of Azure, where you can have multiple VMs in a set. Make sure you're using separate storage accounts for housing the disks for those VMs. Because if one storage account has a problem, you don't want that affecting multiple VMs, so you want to use separate storage accounts for VMs in the same availability set. So you can always make sure at least one VM will be available all the time. Next, I want to talk about a few best practices for configuring the VMs and the applications. We talked about the caching, the fact that we have Azure Blob Cache. The default setting for your data disks is going to be read-only. That's the recommended setting for most normal scenarios. That covers the read-heavy scenarios or a mixed read-write workload scenarios. Only time you want to consider something else will be a write-heavy workloads or write-only workloads, where you want to keep the caching turned off, caching none. That workload will mean long disks of SQL Server databases where you're only doing writes. All other cases, read-only caching is the default mechanism. And if you're using Portal, you can see the screenshot here about how to configure the caching. So the drop-down menu at the bottom is how you will pick the caching option while attaching the disk. And when you use SQL Server or any database for when you're configuring it, the recommendation, use premium storage disk for IO-intensive and performance-sensitive workloads like databases. And you want to use separate disks for data and logs, because you want to use separate cache settings for those. And for TempDB, the recommendation is to leverage the VM's the temporary resource disk. It's an SSD that'll give you very, very fast performance, very low latency. So that gives you a much better performance by leveraging the local SSD for TempDB. And in general, especially when you're migrating legacy application from on-prem to Azure, let's say you have a Linux tool you're migrating, rsync tool you're migrating, things that are single-threaded applications. One of the best practices to use multiple instances of that for improving the throughput. For rsync, for example, you could plan to use separate rsync instances for different folders. That way you can really increase the throughput of the whole system versus one rsync process for the entire system. And there are application-specific best practices for, there's MongoDB, Cassandra, and all other things. There are application-specific best practices. And we work with those partners to produce more and more details on that and post more content. So there are already a few documents out there, and look for more in the near future. Okay. That pretty much wraps up the topic on disk deep dive. Next, I'll turn it back to Ong for files.
All right, I'm back. So let's go over files overview. What is Azure Files? Azure Files is a cloud file storage solution which is available to use with both IaaS VMs and your on-premise machines also. Right? That's one of my personal favorite features of Azure. I could mount a file share on a home machine, and I can copy a file and sync it to the Azure storage. And then from my work machine, I can retrieve the same files, right? So this is a very compelling feature. And then similarly, you can access it from the IaaS VM also, right? Scenario covers, we cover 3 key scenarios. One is lift and shift. You have file system application, on-premise file system applications with, you want to lift and shift it to cloud storage or cloud platform. You can lift and shift it without any code changes at all. That's what Azure Files provide. The second thing is that for high availability, SQL clustering use Quorum, which is a shared drive where they put the Quorum files in there. One of the key features of Azure Files is that multiple instances of clients can access the same files, same folder, right? This address that. Enable backup and recovery scenario. A lot of backup solutions use file endpoint to back up the data. You can use that file endpoint that Azure Files provide to back up the data to cloud storage. So those are the 3 key scenarios that we provide. Let's look at some of the core capabilities of Azure Files. Some of those are our differentiator compared to our competitive solution. Multiple platforms, and we provide, Azure File provide, you can access Azure File from SMB, both SMB and REST. And at the same time, we support both Windows and Linux. So you can mount Azure Files from both Windows and Linux machines. Globally available, accessible from both Azure, I mentioned earlier, on-premise machine, your laptop, or IaaS VM. At the same time, global availability, say Azure Vine, is currently available in all regions right now. We provide same level of durability and SLA as all other storage solutions. So those are key capabilities of Azure Files. Let's go over the roadmap. Since we GA Azure File in last September, since we GA, we work with you, and then we incorporate your feedback, and then we have been working towards releasing some of the core, adding some core features. The first one is file share snapshots. I have a deep dive slide for that. You will be able to take a snapshot of file and then able to retrieve the data from the snapshot file. We are working towards Active Directory integration that will allow you to echo your Azure Files folder using your credential. Third thing we are working towards is that we understand that 5 terabyte limit may not be sufficient for some of your business scenarios. We're going to extend the share, we're going to enlarge the share size and at the same time increase the throughput per share. And we will be providing encryption at rest and then backup integration also. So those are the key, some of the things that we're working towards roadmap. File snapshots, the first one, I think we hope to be able to deliver this feature by end of this calendar year. The rest, we do not have an ETA right now. Sorry? So this is what, so can you hold that thought, please? Because we are bringing up the one of our customer scenario, and then they will address that particular scenario. So I think that at the end of their presentation, if you still have questions, I'll be happy to address that. So this is a good point to summarize differences between Azure Files and Disk, since we just went over Azure Disk session and then just go over the Azure File overview. So key things I want to call out is that for Azure Files, it's for lift and shift scenarios. And this is for like persistent disk for Azure virtual machines. So what's the difference? The key difference is that Azure Files is for multiple access. Many clients can access the same folder. And the Azure Disk, there's a single VM can access to the one disk that you have, right? So those are core differences. And another thing is that Azure Disk provide a very unique capability about caching. So when you are accessing Azure Disk from the VM, we provide blob cache feature, which allow you to burst up to 80, large amount of IOPS and all that, and then you can achieve a lower latency also, right? So those are the core differences. With that, I would like to bring up our customer and the partner to go over the scenario that they use Azure Files to solve their business problems. So, Stephen, it's with Robert for the group.
Thank you.
And then Yap.
Thanks, Ong.
Hey.
Thank you very much.
So they came from all over the world. So thanks for joining us.
Thanks.
Typical.
All right. All right.
That's okay.
Okay.
Bear with me 1 minute, sorry.
So Yap flew in from
Amsterdam. Yeah, definitely.
And then
London, and Stephen flew in from London, right?
London, yeah.
Yep.
So my name is Stephen Cottam. I'm the Chief Technology Officer for Robert Berg Group. We're a structural engineering firm based in Australia. So today we're just going to share some of our experiences with Azure and Talon and how they've helped us to resolve our global collaboration requirements. So first thing would be to explain who we are. So, as I said before, we're...
the clicker or? Yep.
Not just yet. Yeah, so we're an engineering firm 600 employees globally in 10 offices. We've got offices in Australia, London, UAE, and Southeast Asia. So we primarily do with structural engineering. These guys are using complex software to build buildings, producing vast amounts of data, both for modeling information and engineering analysis.
Yeah, so when we came to work with Stephen, he came to us, I think it was 5 years ago, and he asked me, like, we need a solution because we're challenged managing storage, and as an organization, working on all these complex applications, like you mentioned, 3D modeling tools, like Autodesk, Bentley MicroStation, all these types of complex applications. He said, well, we got 600 users. Can you help me in terms of managing storage better? Can you help me with these applications to deliver collaboration? So, yeah, let's move on, Stephen. I know you guys are one of the greatest projects out there, so.
Yeah, so this is the one Central Park. So there's a complex structure at the top. There's the heliostat. It's cantilevered at the top. So we had about 3 offices working on this simultaneously. Hundreds of gigabytes of data just to, work out how this is going to stand up. The forces that were needed to, have the heliostat stand, and cantilever against the rest of the building. There's also just on the left-hand side. There's some vertical hanging gardens. All of this was complex. Lots of data, lots of collaboration between offices. We won the 2014 Best Tall Building Award as well for that project. So as a global organization, there were some challenges on how we can collaborate. So we needed to be able to share files in real time between each office. We also need to share large files. So, there's lots of the outputs from the models. These are big, 300 meg each time. The engineering analysis can be, gigs each time. And this information needs to be in each office, as quick as possible so that, these guys can collaborate. We need to improve productivity and performance. So traditionally, we'd be packaging up work, modularizing the models, sending it out to different offices via FTP, rsync, or some other web-based transfer mechanism. All this time, it was taken away from production. It was slowing down, the efficiency of a project. You could add on weeks of the project just on, the transfer process. With that, we need to reduce the storage cost and complexity. So with the transfers to each of the other offices, we were doubling up on storage. There's also an admin overhead where we're sending these files over there. We need to make sure that the files are consistent, that it's the latest version. We can't have guys working in London and working on different versions in Brisbane, so there's an IT overhead there, there's a project manager overhead there. If we can collaborate and have a central location for the information, then we're going to increase productivity. And the last one was share specialist knowledge and work between offices. So we might have some guys in Australia that are specialists in stadium design or super high-rise buildings or something like that. But we might have the project based in London, but we need to tap into that resources in Australia. As I said, package that work up, sending it over and getting it back is not an efficient way for us to work. So we needed a centralized or some way for us to be able to work at the same time on the same files. So as Jaap said, we contacted these guys 4 years ago for a solution. So
Yeah, that's great. So thanks for highlighting some of these challenges, Stephen. So let me just quickly introduce myself. I'm Jaap. I'm product director with a company called Talon. We're a global organization, software company that helps distributed enterprises solve challenges around managing storage, around distributed storage, around providing the ability to create a single set of data for organizations that allows them to collaborate more effectively. So like Robert Bird Group, all these challenges that he just mentioned, the challenges around managing data, managing distributed storage, managing infrastructure, we believe that there's a better way with regards to how you present storage and how you manage storage in the distributed enterprise. So our software allows for organizations to move data and centralize data effectively into a single set. We integrate perfectly with Microsoft Azure, traditional or hybrid cloud type of deployment strategies, And as a result, we deliver instant global file sharing collaboration with full end-to-end file locking. So I think that's where the question that just came out of the audience around DFSR, how does this work? Our software basically creates a file cache for your branch office with global file locking and eliminates complexity and storage costs for those distributed locations and allows you to consolidate your data more effectively centrally using Azure Files, for example. So when we came to work with Robert Bird Group, they started to centralize their data traditionally in their data center. And now with the availability of Azure Files, we've been able to cut storage costs by moving some of these collaborative workloads, storage workloads, into Microsoft Azure. So Stephen, tell us a little bit about where you were with regards to the deployment, decentralized model, and how you got to this final perfect world scenario.
Yep, so before we introduced Talent originally, as we said before, we were packaging up work, sending it to the different offices. The collaboration was pretty painful. There was a lot of downtime in the transfers, and as I said, the IT overheads. Obviously, you can see that we're fully meshed, so the offices can see the other file systems, but with high latency between Australia and UK, you just can't access the files over there adequately for it to be usable. So
you were actually managing islands of data, right?
Correct, yeah.
So basically when you had all the local storage, you had your local backups, you were challenged with managing, especially in different time zones. As you're working from London and Australia, it's very, very hard. So you picked that up and moved that towards a centralized model, right, to solve some of these challenges.
Yeah, so when we introduced the Talent appliances, we were able to then say, well, look, if the project's being run from London, we're going to centralize that data there, and all the other offices are going to access that data through DFS namespace, and then through the Talent, redirected back to London. As the guys are accessing that files, it's being cached in remote offices, and they're then able to work in real time on projects. So using Talent, we were able to eliminate latency, reduce the bandwidth costs, and reduce the complexity at the branch level for backups and managing the consistency of files between offices.
Yeah, so I think when we started to engage, you had like a couple of servers sitting out there, a regular file server, a backup device, you had acceleration services, all kinds of stuff. And we've been able to consolidate that in a single type of branch office infrastructure. So running on top of Windows Server, aggregating all of your data and presenting the active data to those users in those offices, and basically consolidating all of those traditional Microsoft services that you need onto a single instance. So
Talent worked really well for us. It changed the way that we could work. We could actually collaborate in real time on a global level. We could actually increase the time for project delivery. So we started to think, well, how can we extend the Talent experience, for our external users, architects, our clients, and get that information to over these guys as well. We don't want to give them access directly to our file server, but we do want to have a shared area where we can actually work with our, as I say, our external users. And that could be our workshare partners, which are outsourcing.
So you still got the benefits of managing your NTFS permissions and ACLs with our software using the Azure Files workload. So you can see Stephen has his central storage in London, and he now uses the Azure Files solution to consolidate his data and leverage our software to bring the data closer to the end user so they can actively collaborate on those projects that may be gigabytes in terms of file sizes.
So, as Ong mentioned earlier, one of our next steps, obviously we're going to continue to use Azure and Talent as it is. We wanted to move some of our archiving and our disaster recovery into Azure. One of the big reasons we didn't do that was because there was no snapshot capability. That was a big issue for us, but we're excited to see that that's now coming. So our sort of next steps would be to move the disaster recovery, the archiving solutions into Azure. Okay, so using Talent and Azure in conjunction, we've been able to increase our collaboration for all offices globally, including our outsourcing partners. We've increased productivity. We've modernized and streamlined our storage capabilities by entering into Azure. And we've now taken a first step to potentially move our disaster recovery and archive data into Azure.
All right. So thank you.
Thank you.
Thank you very much.
Thank you, guys.
So I understand our session stem between you and the lunch, but since you stick around, we have a demo for highlighting Azure files. Right. So how many of you are still running legacy FTP server on-prem? Quite a few. So our demo will highlight how you will migrate legacy FTP server to cloud using Azure files in Azure. So problem, just mention that, and then you move FTP server, on-prem FTP server to IaaS, and then move Azure file share to Azure, local file share to Azure files. So basically, we put together the demo within a few hours, and then we were able to do that. In fact, about 6 to 7 hours, and then we will do that, and then we hit me offline, and I'm happy to share the steps with you. But what Sirius is going to also do the live demo of how what our configuration is, and then how you can transfer data from on-prem to Azure files using FTP service. Sirius?
Okay. So what we are seeing here is an FTP server setup with a file share, Azure file share behind the scenes. So this is the FTP server. As you can see here, when I see the configuration of the server, you will see that it's pointing to one of the file shares in Azure storage accounts. So it's an FTP server behind the load balancer pointing to the Azure file share as the storage location. And on that VM, just so we can look at the data, we also mounted the file share, and you can see the data here. So this is a file share that the FTP server is pointing to, and currently it's all empty.
So let me add to that. We configure 2 IaaS machines behind the load balancer so that if one goes down, one is always up. And then both file share configuration that Sirius just mentioned point to the Azure files. So that every time, through FTP client, which you would install on-prem, transfer the data through FTP service, it will get deposited into the Azure file. So that's the concept that we're trying to demo.
Okay. Now I'm going to flip back to the local machine here. So this is my FTP client that connects to the FTP server that we just showed you. So it's connecting to that here. And I have some pictures here, and I'm going to try to transfer one of those pictures over to the FTP server here. So FTP has finished. So now let's go and look at what's on the FTP server. Well, as you can see here, the picture I transferred has come up.
So it's already in the Azure file storage.
Azure file storage, yeah.
All right, double click on the file. All right, scroll down, please.
Yeah.
Yeah, this is Melon. So one of my colleagues and friend helped put together this demo, and she spent quite a bit of time, and then she said, hey, she wants her dog to be famous. So I said, sure. Give the picture, and then that's Melon, and then thanks to you, Min, also. So thank you, everyone, for attending this session. And we have a handout, best practices handout. They're handing out when you exit, and then our email alias is there. If you have any questions, let me know. I'll stick around also. I think we have 5 minutes also. So if you have any question, come to the mic. After that, I will stick around and answer any question. I think our friends from Talon and Robert Bird will still be here also. Thank you.